All right, everybody, section 1.14, infinite limits. So I want to review real quick a topic from AP Pre-Calc. You might remember, you might not. But we talked a lot in that class about one-sided limits as we're approaching vertical asymptotes. All right, so as we approach 2 from the left, so again, that means go to the left of 2. All right, when we're to the left of 2, as we get closer to 2, the graph is headed up. So the one-sided limit, as we approach 2 from the left, the y values are getting closer to positive infinity. Now, to the right of 2, so when we're over here, right, to the right of 2, as we get closer to 2, the y values are headed down forever, so they are going to approach negative infinity. Sometimes you'll also see it because we never actually get to those values. You'll see the answer, instead of being infinity or negative infinity, they might write does not exist, okay? But we are typically going to write either infinity or negative infinity. All right, so we have a question here. We're asked for the one-sided limit as x approaches 2 from the right. And so we've learned previously that we can just take this value and we can plug it in for the x's. So if we do that, so if I plug in 2 for both the x's, I get 4 on top and I get 0 on the bottom. Now, what does that tell us? Well, we can't have 0 on the bottom. It's undefined. But on the graph, that produces that vertical asymptote we were just talking about. Okay? So that's how we get something like this right here. We get a vertical asymptote when the bottom of the denominator is equal to 0. Now, here's the question. Because we can actually answer this, because there's a vertical asymptote, we know the answer is either infinity or negative infinity. So to determine which of those two is correct, here's how we're going to think about this. Let me get rid of this sticky note real quick. Okay, is it going up forever? Is it going down forever? So because x is approaching 2 just from the right, we are going to plug in a number that's just to the right of 2. All right, so we could, 3 is to the right of 2, but I want to get a little bit closer than 3. So I'm going to plug in for these x's here. I'm going to plug in 2.001. Okay, there's nothing magical about that number. It's just a number that's very close to 2. All right, so we're going to divide. If I replace both x's with that, we've got 2.001 minus 2. So that would give us, in the numerator here, that would give us 4.001. And our denominator would be 0.001. So what does this divide out to without using a calculator? Well, because these are both decimals, I'm just going to move the decimal to the right 3 times here and here. We can do that because we're doing it to both of them. So if I move the decimal place to the right 3 times, the top is just 4001 and the bottom is just 1. All right, so now we have a large number on top, positive, and a 1 on the bottom. So what does that tell us? Well, this number is going to be closer to a positive infinity than it is to a negative infinity. All right, and so because we have a large number on top and a small positive on the bottom, they're both positive, we can go ahead and say, all right, when we're to the right of 2, this is approaching positive infinity, not negative here, positive infinity. All right, last example for this lesson. Again, it's going to be super short. We're going to find the limit as x approaches 3 from the left. All right, so when we're to the left of 3, again, we can go ahead and just plug in 3. The issue here is that we get 0 over 0. Okay? Now, previously when we've gotten 0 over 0, we factored and canceled. The issue is these don't factor. So there has to be another way to think about this. And because it's a one-sided limit, we're going to plug in a value that is very close to 3, but just to the left of it. So I'm going to replace both x's here with I'm going to go 99. There's no magic decimal place to go to. So I'm just going to plug in 2.99, and that is just to the left of 3. All right, so in the numerator and the denominator here. So 2.99 minus 3. All right, so if we simplify the numerator, we get 0.01. And if we simplify the denominator, we get the absolute value of negative 0.01. Now, absolute value just makes something positive. So we get 0.01 divided by positive 0.01. And we know that any number divided by itself just gives us 1. All right, so even though when we plug in 3, we do get 0 over 0, when we plug in a number to the left of 3, we're not getting 0 over 0, we're getting 1. And so that's what the limit's going to equal here. All right, so that's it for 1.14. I'm going to do another video for 1.15 as well, and then we'll get back to the normal videos after that. All right, stay flawless.